Let's try to understand how to do addition, subtraction and multiplication of vectors when we have Cartesian vectors. Now here is an example with which we can understand the concept. Given vectors p equals to 3, 1 and q equals to 2, 3, calculate p plus q. Now to do p plus q, we can do triangular law or we can do parallelogram law, correct? Either way we can find p plus q. So let's do this and then see how to do it, right? Let's do p plus q is, we can do it graphically first here and then we will see how to get in a simpler way. Vector p is 3, 1. So we can start from origin and say 3, 1 means 1, 2, 3 and 1. So that represents vector p, right? So let me draw this line with tail at 0 and head at 3, 1, and that represents vector p for me. So this is p, right? Okay, and now let's add q. Adding q will mean you can put tail of q on the head of p and then we can get addition of p and q using triangular law, right? In triangular law we put tail on the head, right? So 2, 3. So from here 1, 2 and 1, 2, 3. So that's q with tail at this location 3, 1. So we can do extend like this. So that is q for us, correct? So that is q. Now p plus q will be the vector starting from the tail of p to the head of q, correct? So this vector from p to q becomes p plus q for us. Now from the grid we can see that the answer is 5, 4, right? That point is 5, 4. So we get p plus q as 5 and 4. And we used triangular law on our grid and got the answer. Do you see that? How simple. But with Cartesian vectors, we can do it in such a simple way. I'll show you. What is p? P is 3, 1, right? 3, 1 plus q is 2, 3. So let's add them. 3 plus 1, or 3 plus 2 is 5. So we get 5. And 1 plus 3 is 4. We get the same answer. Do you see that? We get the same answer. So if the vectors are given in as Cartesian vectors, then addition subtraction is addition subtraction of their respective x and y coordinates. Do you see that? So that's how we do it. Let's do p minus q using this technique which we just learned. So p minus q should be, we have 3, we'll write 3. So we are writing p first, right? 3 minus 2. Now let me write 3 minus 2. That is my x coordinates, right? And the difference in y coordinates are 1 minus 3. And the answer should be 3 minus 2 is 1 and 1 minus 3 is minus 2, right? So as an exercise, I would like you to do it on the grid and check your answer, right? Now, p minus q is like also adding minus q to p. So what you can do is, this is your q, right? So from here, what is minus q? So q is 2, 3, minus q will be, it is going in the opposite direction, right? So instead of going 2 to the right, we can go 2 left, and then 3 up, we can go 3 down. So if we do that, then 1, 2 left, and 1, 2, 3 right. So we reach this position. Do you see that? And what is this position? This position is 1 minus 2. Do you see that? And therefore, this is your answer for p minus q. So graphically, we can do it like as shown here on the right side. Do you understand? Now let's do the third part, which is a scalar multiple. 2 times p. So what we do is, 2 times p is this vector, and we can extend it further by twice the length, right? So it becomes twice the length. Same vector again, once again, right? So this vector is 3, 1. So from here, 2p means add it once more. So 1, 2, 3, and 1. So that becomes another p, right? So p plus p, we get 2p. Do you see that? 2p. And the coordinates for 2p is 6 and 2. How do you get 6 and 2? 3, 1. So we get, this is 2 times 3, 1, which is 6 and 2. Do you see that? So that is how we do vector algebra using Cartesian vectors. It's very simple. So in future and in many problems to come, we like to translate the question so that we get their Cartesian vectors, and then we can do algebra very easily. So that will be a strategy to work out many problems. I hope you understand and appreciate it. Thank you. All the best.